Hello, everyone. This review topic will be an Algebra 1 topic, simplifying radical expressions. So when we simplify anything under a square root sign, remember there are certain numbers that we can simplify more than others. The square root of 1 is 1. There's some other numbers too that we really like because they're perfect squares. 4, 9, 16, 25, 36, 49, because the square root of these numbers is a whole number. Square root of 9 is 3, the square root of 16 is 4, the square root of 25 is 5, the square root of 36 is 6, the square root of 49 is 7, and so on and so forth. All right, so when we're doing this problem, what we want to do is we want to simplify the square root of 27. So how can we factor 27 so that it has a number that we can take out? Well, 27 is the same as 9 times 3, right? And as we just saw, the square root of 9 is equal to the whole number 3. So what we can do is we can really write this as 3 square root of 3. Right? Because the square root of 9 is 3, so that's why it came outside here. And then the square root of 3, well, that's not a whole number, so we just leave it inside of the square root. So over here, you would say 3 times the square root of 3. That's how we simplify the square root of 27. The square root of 27 is equal to 3 times the square root of 3. Okay, let's try one more. What's the square root of 12? The square root of 12, what two numbers can we multiply where one of them is a perfect square? Well, we could do 2 times 6, but neither of those are perfect squares. We could also do 4 times 3. One of those is a perfect square, 4. The square root of 4 is 2. So this is equal to positive 2, and the square root of 3, because the 3 is still underneath the radical sign. So another way to simplify the square root of 12 is to write, 2 times the square root of 3. Let's go and skip to a higher level. Let's go a little bit higher. All right, let's try this one. The square root of 18. Let's see, the factors of 18 are 1 times 18, but 18 is not a perfect square. 2 times 9, 9 is a perfect square. 9 is 3 times 3, right? So since the square root of 9 is 3, we can take it out and write it as a 3, but the square root of 2, the 2 is still left inside. So our answer is 3 times the square root of 2. All right, here we have one that's a little bit tougher. So we have 3 times the square root of 242. Let's try breaking this down into smaller digits that we can think of. Well, since 2, 4, and 2 can all be divided by 2, we know that this is an even number. The whole thing can be divided by 2. So let's rewrite this as 3 times the square root of 2 times, well, let's see, what would we multiply 2 times to make 242? Well, 2 times 1 is 2, 2 times 2 is 4, and 2 times 1 is 2. So let's make sure this is right. 2 times 1 is 2, 2 times 2 is 4, 2 times 1 is 2. Yes, 2 times 121 would be 242. Oh, look, we actually do have a perfect square here now. What's the square root of 121? you might recognize that as 11. So this on the outside is really 3 times 11 because we can take the 11 out. This 121, the square root of 121 is 11, but the 2 is still underneath. So on the outside we have 3, but we also have 11. So we need to multiply these. 3 times 11 is 33, and the square root of 2 is still left inside. There's our answer. 3 times the square root of 242 can be written as 33 times the square root of 2. All right, let's simplify this one. 147. Let's think if there's anything that we can divide this by to simplify it. Well, I see a 14 and I see a 7. And I know that 14 and 7 are related because 7 times 2 is 14. So that gives me a sneaking suspicion that this actually might be 7 times something. Well, 7 times 20, let's see, 7 times 20 would give me 140. And then there's only 7 left, so that would be one more 7. So this must be 7 times 21. Let's check that. 7 times 2 would be the 14, and then 7 times 1 would be the 7. This is correct. And look at this. I can break it down as 7 times, well, what's the only way to factor 21? 7 times 3, right? Well, since this is 7 times 7 times 3, what is 7 times 7 really equal to? That's right, this is the square root of 49 times 3. And the square root of 49 is a perfect square. So if we take out the 49, that would be 7 squared. So this is really 7 times the square root of 3. Notice when we have two 7s in here, you can think of it like when we have 2 of the same number in here, we get to bring one of them out and the other one goes away. And that's because 7 times 7 is 49 and the square root of 49 is 7. Seven times the square root of 3. Okay, let's do one more so that we can get up to the close to the 90. Remember, you need a 90 for an A. 9 times the square root of 75. Well, we can break down 75 so that it has a perfect square by doing 9 times the square root of 25 times 3. Sorry, this is a radical. What's the square root of 25? Well, the square root of 25 is just 5, so you can bring the 5 out. The square root of 3, that doesn't have a perfect square. So 9 times 5 is 45. And the square root of 3 is still left inside of the radical. So this is 45 times the square root of 3. All right. This is very similar to our last one, so hopefully you are prepared. Try this one on your own. I'm just going to give you the answer. So see if you can explain to someone why the answer would be 6 square root of 5. See if you can explain the steps to get there. And let me just check because I did that in my head. If you can explain that to someone, then you are ready to do this task.